First of all, my name is Camila Campos. I'm a developer at Creditas. I'm also organize Rails Girls and Women Dev Summit. You can find me on Twitter as Campus Mila with 2 A's. So as I said, I work at Creditas. Creditas is a platform for online collateral loans, which is a loan that you use a car or a house as collateral, and you can get a high quality credit with lower interest rates. You can find us at creditas.com.br. We have a lot of open positions, so if you're looking for a job, we are hiring a lot. I also organize Rails Girls, which is a project to include more women in tech. You can see here that we don't have a lot of women here. So we do this initiative to try to have more women here. We do this with a two-day Rails workshop, and the main goal is to serve as an inspiration to the girls so they can enter the world of technology. I also organize Women Dev Summit, which is a come together of 4 communities, and the main goal is to encourage women that are already in tech. And we do talks and workshops and panels and everything. So let's go to the talk about stop hating your test suite. So I'm making a huge assumption here that you do hate your test suite, that the answer to this question is yes. But why do we hate our test suite? If we do hate our test suite, why do we hate that? But before that, we need to understand why do we write tests at all. So I think the main reason is because we like tests, right? So, but that's not just it. We learn from like our experience that tests are really important, that they make our code better, but it's not just it. We also write tests because they give us high confidence and also understanding. And when I'm talking about high confidence, I'm talking about my test guarantees that my code works, and it also guarantees that I can refactor my code. So if I already have my code there, if I have a test, I can refactor it. I have more confidence in that, and also that I didn't break anything that was already written before, was already working before. So if I have a test and I add new functionalities, my test guarantees that everything that was working before I add something new, it continues working. And when I'm talking about understanding, I'm saying that my test is easy to use, easy to modify, and here I'm not talking necessarily about refactoring. I'm saying like you already have a code that works and you want to change the behavior of that. So if you have a test, it's easier to modify your code. And also it guides the design of your code. So especially if you're using TDD, and I'm taking a minute to talk about this. So TDD, if test-driven design, I guess most of us already know what it is. So you write a failing test, and then you write a code to make that test pass. And then you can refactor your code or your test. And then you keep doing this. This is called TDD. But I like to say that TDD is test-driven design because it's the test is like the first user of your code. So you can see if your code is working, if your code is designed like in a good way. So the test designing how good your code is, because like it's using your code even before you implement it. So if tests are so cool and they give us all this good stuff, why do we hate our tests? And I guess we have 3 main reasons why we hate our tests. First, because they are slow. Also because they can be complicated to write or to understand. Even unnecessary. So we write some tests that we think that we don't really need to write them. So this is why we end up hating our tests. I'm going through each one of these, explaining why we do hate our tests because of this, and what we can do to like improve and not suffer from this stuff. So first is slow tests. So when we think about like our test suite and like the time it needs to run all of our tests, we expect like the more tests we have, the more time it will take to run our tests. But we expect it to be linear. So if I have 100 tests, it should take like 10 seconds. If I have 1,000 tests, it should be like 10 plus 10 times 10 times like seconds to run this. But what really happens is just red line there. So the more tests I have, the more time each test takes to run. So why this happen? Why like we have this exponential curve instead of the linear one? I guess most of it stays on this test pyramid here. And for those who don't know, so it's like the levels of the test that you have in your suite. So the end-to-end test, which is in the top of the layers, is the test that mimics the user behavior in your application. So it's like the real user using your application, your software, your mobile application, your website. But instead of real user using like a real person, it's a robot using it for you. It's because it's an automated test. On the bottom layer of the test suite of the pyramid, there is the unit test. So let's imagine that we have like this tree of classes interacting with each other, and a unit is like the smallest part of your system. So some people say it's like just a single class, a single method and a single class. Some people say that it's like a couple of units, a couple of classes working together. But no matter what you think of a unit, if it's a couple of classes or just a class and a method, the thing about a unit is that it's the smallest part of your code that can be testable, that can be tested. So no matter what you think a unit is, I'm not entering the discussion now. The unit test is that when you have a unit and it interacts with something else, with some other collaborators, you don't use the real collaborator here. You use the test double instead, which is like an object that fakes my real collaborator. So you don't even need to have the collaborator ready or implemented, but you can use like a test double or a mock or a stub, something like that, to mimic the behavior of your collaborator. So your unit is isolated from your collaborator. But they have a problem. So like this GIF here, for example. Like the trash is fine, the thing that the hand dryer is fine, but like the two of them working together are not just fine. This one is the same thing. So the door works fine, the locker works fine, but the two of them working together, not so fine. So I could show you a lot of GIFs like this, but they show a problem of unit testing. So I test two units separately, but when I use the two of them together, they may not work as well. So that's why we have integration tests. So integration tests are the ones that use like a couple of units working together. They usually test some functionality. So if you're testing an API, you usually test one endpoint or maybe two of them working together. And so it's broader than a unit test because they test some units working together, but they are less expensive and less they take less time to run than the end-to-end test because they test just a small functionality, just in any point, not like the whole system, like a user was using it. And then we have the test param like made. So it's important to note to see here that like the unit tests are really fast to make, to code, and they're really fast to run as well because they are about a single unit, the smallest part of your code. So they are small as well. Running them is fast and creating them is easy as well. In the other hand, like the top of the pyramid, the end-to-end tests, they're really slow to run because they really test the whole system as like they test the system as a whole. They mimic a user behavior. So they, for example, if you are testing a website, you need to open the browser and enter the URL and like fill out the forms and click the buttons and see if the screen that showed up is the one that you expected. So they are slow to run because they do a lot of stuff, and they're also expensive and to make it. They're expensive to code because they need to do a lot of stuff. And integration tests, on the other hand, they are not as simple to do as unit tests, but they are simple enough that like less simple than the end-to-end test. So why I think the slowest test is, the problem with slowest test lays in this pyramid, because often a pyramid Yeah, before that. So at Creditas, for example, we have like 13 end-to-end tests. It takes like about 15 minutes to run, just 13 tests. And unit tests, we have like almost 6,000 tests, and it takes less than a minute to run on ERCI. And integration tests, we have like half of it, and it takes about 3 minutes to run. So you can see like how expensive the program looks the way I showed before. So the thing is that this pyramid often look like this. So you don't really know what is a unit test in your test suite. You don't really know what an end-to-end test is, what an integration test. You see there are some tests that should be integration and there are unit, and there's also that tests that are like in the middle of two layers. So you don't know. You look at the test, you don't know if it's unit test, if it's integration test, if it's end-to-end test. So with this, you know, if because of this, our tests tend to run slower. So my advice here, when you think about your test program, try to focus on your unit tests. Like they are the most important tests of your test suite. So focus on them. You probably have a lot of them, and try to make them separately from the other the other levels of testing. Then think the flows of your application that really need to be tested. So at Creditas, for example, like when a user requests a loan, this is a really important flow for us. So we have an end-to-end test that we cover this functionality. So we think like what are the most important flows that need to be covered, and we have an end-to-end test for that. Everything else, and also like the ones that are also covered by an end-to-end test, it's important to have integration tests to make sure that everything is working as a whole. So, and also like for each of the layers, think about rules and convention, about how you use your data, how you interact with your external dependencies, how you interact with collaborators of your classes and what you're testing. So at Creditas, for example, the rules and conventions for each one of these tests, we like use them separately. So the end-to-end tests are in a separate repository, and we have two separate like folders, directories for integration and unit tests. And in the end-to-end test, we use the real database. We use like the collaborators because it's a black box test, and we use external dependencies, but like fake ones, or like the staging or homologation external dependencies. On integration tests, we don't use the external dependencies, but we have the database. Sorry, it's a note there on the collaborators, but we do use the collaborators on unit tests, on integration tests. On unit tests, we don't use anything. We just test the class, the method. So we don't interact with anything else than my unit, that's my single unit. If you don't have that, your test you should probably like run faster. So yeah, then we have this test program that make your like if you have the separate responsibilities for each one of the classes of the test levels, your test will probably run faster. And also try to you don't need to run your test like every time. You don't need to run every test level every time. So you can, for example, I run my unit test when I'm changing a class. I'm changing my code or doing something new. I just run my unit test. Before I commit something to my branch on GitHub, I run my integration test as well. So I'm sure that I didn't break anything else. And when I'm testing my feature, so I think I'm done. I already developed everything that I need for this feature. So I do a deploy to a staging environment and run my end-to-end test. So I don't need to spend that 15 minutes every time. I just need to run when I'm testing something. So, and then we get to the second part of the why do we hate our tests. So complicated tests. When I say complicated, I mean tests that are hard to read or to maintain or understand. And there are four main reasons why they are complicated. So maybe they are unclear, maybe they are messy or obscure, or maybe they are too smart. They are doing too much. So I'm going through each one of them as well to explain why and what they mean. So unclear tests. When we're talking about unclear tests, there are tests that you can really get what is going on there. So it's it seems okay, but like you can, it's not clear what he's doing. So we need to understand first that test is something that guarantees that real code is working. I think like everyone knows that. But this something that test is actually code. So test is code. Test is also code that guarantees that our real code, like our production code, is working. But also, more than that, test is an untested code that guarantees that our code is working. Of course, we're not testing our tests because that doesn't make any sense. But, oops. Yeah. But our test code should be simple, should be small, should be easy to read, and should be right to the point. Because if they are not all these things, we won't understand them. They will be not clear. It's like you hate your test because you know, right? So, for example, if we had this test here, so I'm saying it sends a message. I have a person here. I have a messenger that has a person and greets something, and my expectation says that my response should be "Hello, John." But if I look to my message here, to my description of my test, it just say it sends a message, and I don't really get what's going on here. Like I don't know what message it sends, who sends the message. But if I change this to it greets a person, I now know I probably have someone that greets a person. So it says hello or something like that to a person. So my test is much clearer just with a good description. So bad descriptions are also a reason why we hate our tests. So try to avoid that. Try to make our test the more clear that you can. Also, if I have the same test here, but now I have like the person has also last name and age. It doesn't have just the name. But my expectation down there only have the name of the person, right? So I have a problem here that is misleading unimportant stuff. So if I look at the setup of my test, I see the name, the last name, and the age of the person, but in the expectation, I don't really care about it. So I might think that it is important for my method because of some reason. So try to avoid that. Try to use just a name if the name is not if the other stuff is not important. There are ways that you can do that, even if your class needs to have this on their constructor. Also, is the name John important? So it's like it should always be capitalized. If not, make it clear that it's not important. So you can have like any name there. You don't need to be formatted, or you don't need to be anyway important. So you don't raise any questions there. And my test will be much clearer if I have like just this name there. I know like the only thing about a person that is important is the name, and the how the name is not important. So try to avoid misleading unimportant stuff. And now we go to the messy part of complicated tests. So here we need to remember always that tests are code that only do three things. They set everything that they needed, then they call whatever they are testing, and later then verify if the expected behavior. So they verify if it happens what it should happen. This is also known as AAA or 3A's of testing, or AAA, I don't know, which stands for arrange, act, and assert. This is also known as X-unit patterns, but we have a different name here, which is setup, exercise, and verify. So I'll talk about these steps like for the whole talk later. So I'll probably like change and use setup and action verify. So don't mind me. On X-unit patterns, we also have the tear down part, which is like undo everything that you did in your setup, but it's not really important here. So I'm not talking about this. And usually on the tear down part, the test frameworks that you use, you probably do it for you like automatically. So this is mainly talked about in this book, X-unit patterns by Jared Meszaros, and there's a version available online for free. I really recommend this book, and most of this talk is based on this book. So the things tests do. So take the same example of a messaging greeting a person. So I have a setup part that I initialize my person. That's what my test uses. I have the messenger that takes a person and greets something. So I'm testing the greet method of my messenger. So I'm exercising the method here. And later I'm expecting the response of my greet method is what I expected. So the response is Brother John. So the verify phase. I think about this. It's really simple. Just like put a blank line between them. So don't put them all tied together, because if you have like some space between them, just a blank line between them, you can look at like anyone that looks at your test will be sure where each part of your test is. So they will be sure where the setup part is, where the exercise part is, where the verification is. So it's just simple stuff that you can do that will make your test a lot more clear and a lot less complicated. Also, the order is important here. So take like a similar test as an example, but here I have it sends a mail to a person. On my setup part, I have a mailer here that I use a test double because I'm unit testing my class. I have an expectation right after that because I use my mailer after that. So I need to verify the behavior before I actually call my mailer because it doesn't know how to respond to notify, for example. So I need to use the verification part before the exercise part. And then I exercise, I call my method send email, for instance. So don't do that. Don't use the verification part in the middle. Respect the order of the three things. So use setup and then exercising and then verifying your test. So a lot of test frameworks, and here I'm using RSpec on Ruby as an example, but I know JavaScript and a lot of other frameworks, test frameworks can do that. So you can use like other kind of test doubles to use the verification like on the bottom part of your test, and then you respect the order. So you make everyone pretty good about this. And so everyone that looks at your test, you know where the setup is, where the exercise is, where the verification is. So every test you make, every test that everyone in your company makes, for example, and everyone that looks at a test will know where each part of the test is. And now we go to obscure tests. First, congratulations to you that got through here. It's the half of the talk. So congratulations. So obscure tests is that test that we don't really get what is going on there. It's the test that you're like, I don't know what it's testing at all. So let's take the same example of greeting a person, but now my messenger also knows how to gracefully greet a person. So I have like two tests for that because he knows how to greet like in two ways, right? So I have the person here is the same thing that I had before. I have my messaging greeting a person, but now it has like the greet and the fancy greet method. So that's why we have two tests for that. And the expectation is really like just changing a little bit. So as good developers, and we like dry code, right? We like to have our code as less repetitive as possible. So we use a lot of stuff that our test frameworks you can give us to make our test less repetitive. So in our spec, for example, we have the let. I know JS Mocha also has the let convention. So we use let to have just one person declared. So I use let, I have person in just one place, and then I use this person in both my tests. I also do this for the messenger. That is the one that executes my test, the method I'm testing. And then I have like much smallest tests and much clearer, so I don't repeat anything there. And it looks pretty great. It's like it sounds just fine. Also here, you might think that any name here is it might be some like a little bit obscure. So we use the person name here to make it clear where this any name came from, not just a random string at all. So you don't need to repeat the person name as well. And this looks really fine. It's actually better than it was before. But if we keep adding more functionality, like let's think like the messenger knows how to do other stuff right now. So entirely different thing, or like a new way to greet a person, and we keep adding tests to that and adding more and more and more. And I guarantee you that you can really see what's going on here. You can really see the tests here. But I'll zoom it out for you, the bottom test there. So if you look at of just this test, just one test here, I don't really get what is going on here. I don't know what my messenger is. I don't know what this person name is. I don't know who the person is. I don't know why my messenger is responding a person name for some reason. So it gets really obscure. And when I'm looking just for this test, I'm like, what is going on here? Because this introduces a problem that we call mystery guess. Because it's a guess, it's something that don't belong to my test, that is mystery. I don't know where it came from. It came from. So when we are talking about tests, it's really better to have repetitive tests. So to understand something, you can have like repetitive tests. It's better to have repetitive tests because when you look at each one of the tests, and no matter if you have like 2 tests or 100 tests, you get what the test means just looking at each one of them. So my advice here is forget the dry when you're talking about tests. And now we get to 2 smart tests. It usually means that your real code needs some refactoring. So, for example, if you have the setup part really complex or big, you're doing so much stuff on the first part of your test, usually means that your real code have too many dependencies, or maybe not too many dependencies, but too many interactions between them. Also, if your tests have multiple verifications, so if it expects a lot of things, it usually means that your test is doing too many, it has too many responsibilities, it is doing too many things. Maybe you should think about like refactoring and changing to 2 or more classes. If you have multiple exercise steps, which is like a lot of you need to do a lot to verify some behavior. Usually means that your API, the API of the test, the code you're testing, is too complex. Like you need to do a lot of stuff to do one thing, to verify one thing, just one thing. We mean like in one test. So you should probably like change the way you call your methods, the way your methods are defined. When you have complex code in your test, so for example loops, or you need to mock private method calls, so usually means your code is doing too much. Maybe you should think about refactoring it and doing also like separating into 2 or more classes. And now we get to the last part of the talk. We're talking about unnecessary tests. So unnecessary tests are the ones that are intermittent. So if you run your test twice or more in a row, so I run my test now and it fails, and then I run it again and it passes, we usually think they're unnecessary, because like, why do I have this test if I running it just for for no reason, just because like in the next time I run it, it'll pass. It usually happens with like JavaScript test that it depends on timeout. So when I run the first time, it takes 3 seconds, and my code needs to run in 2 seconds. And the next time I run, it takes like 1.5 seconds, so it passes. Or also they are order dependent. It's also a reason why they are intermittent, for example. So it usually happens because of dependencies your code have. So for example, if I have 2 separate classes and they have the same dependency, if I run this test, but like the only one of them requires and imports this dependency. If I run the test for this code before this one, my test will pass. But if I run my test and it runs the one that doesn't have the dependency runs after the one that has, my test won't pass. So this is also a reason why we end up hating our tests, or we thinking they are unnecessary. And also because they are fragile. So for example, tests that depend on date, for example. So tests that pass just before, if you run them before 9 p.m. because of the time zone, because like in Brazil, the WR time is only 3 minus from uh, the global time zone. So these are some of the reasons we think our tests are fragile. And also because we think they are redundant. So let's take just 3 of tests for example. If I have like a controller that interacts with a servicer that calls both a repository and a model. If my repository there, if my class there answer 2 different things for some reason for the method that I'm using there, I should have 2 tests for that. So a test for each one, like if I call my method and it can have 2 possible outputs, so I have 2 tests for that. But my service that uses this repository, I'd also make 2 tests for that. And the same thing for my controller, because I need to have everything covered, right? But the thing is, if I change my repository to answer C instead of B there, I need to go changing my service and my controller all the way up. If I have like this, here we have just 3 layers there. But I could have like 5, 10 classes before like I need to that I need to change because I changed just one more a small thing there. So we expect that if I change just a small thing in one classes, I should change it like 1 test, 2 at most. But I need to change like 10 tests. It's not good. So redundant tests make us think that they are unnecessary and make us think that we don't really need them. So there's no really good answer for that. You can have for a redundant test, you can mock everything. That is probably what is going on the test param, the test flow that I showed you. So you mock every response, and you need to have the both tests for each response, or you can have maybe fewer tests in each level or each layer of your application. So for example, in the controller, maybe I don't need to test the 2 paths. Maybe I can have just a test for the happy path. This is up to you. I guess you need to like choose between what makes more sense in the case that you're testing. Maybe like you guarantee that it was working in the layers before, so you can have less tests and it's fine. So now we have all the 3 reasons why we hate our tests going through, and I told you some things that you can do to hate them less, to you keep loving your tests. So yay, we got through that. And just before I finish, I would like to end you with a profound phrase. I don't know. So a lot of people say that bad tests are better than having no tests. So if you have a test that goes through like these 3 things that are slow, or they're complicated, or they are unnecessary, this is better than having no tests at all. But I'd like you to think about this as actually having no tests is better than having bad ones. Because when you have no tests, when you have bad tests, you don't get the benefits of the testing. So you don't have tests that you can trust them. You can trust your tests. You can understand your code based on your tests. So your test doesn't give you anything at all. So you might end up trusting them because you don't really know that they are bad, and you end up with a bug in production, which is not fine. If you have no tests at all, you don't trust anything, right? So you need to test everything manually. So you have the test, but it's manual, and you have a lot of since you don't have any trust, you don't have any confidence, you need to test everything manually. So if you get anything from a talk, I'd like to remember this, that having no tests is better than bad ones, and try to avoid the bad tests so you can get all the benefits of testing. And that's it that I had to say to you. My talk is available on this link, so theconf-camila. You can find me on Twitter at Campos Mila, or my LinkedIn, Camila Campos Ramos. And that's it. Thank you.